Computers are making more and more complex decisions that affect our daily lives, from getting a credit card to choices made in an emergency room. But how do they actually learn to do that? Well, it all comes down to how we teach them. And as it turns out, there are two totally different ways to go about it.
To really wrap our heads around this, let's jump right into a pretty high-stakes scenario. Let's say you're a huge credit card company. Every single day, thousands, and I mean thousands of applications hit your desk. Every one is a real person hoping to get a new card. And you have to make the call, approve or deny. Getting that right thousands of times a day, that is a massive, massive challenge. And look, this isn't just about money. The exact same kind of thinking happens in hospitals, where doctors have to figure out which patient gets that last spot in the intensive care unit. We're talking about decisions that can literally be life or death, and they are increasingly being helped by a really powerful tool. And that tool? It's called machine learning. At its heart, it's just about letting a computer learn from data. Just like we learn from our past experiences, a machine learns from past data to get smarter at a task. But what does that actually look like? Let's start with the most common way. All right, the first way is what we call supervised learning. And honestly, the easiest way to think about it is like this. Imagine you're studying for a huge test, but you've got the official answer key right in front of you. For the computer, this table of old loan applications is its past experience. Each row is a decision that was already made, with all the details for each person: their age, if they have a job, own a house, their credit rating, the whole thing. But the most important piece of this whole puzzle is that last column, the one labeled class. This tells the computer the final outcome for every single past application: yes for approved, no for not approved. This is the answer key. This is what the machine is going to study. Okay, so our machine has studied all that past data. It's done its homework. Now a brand new applicant shows up. A young person, no job, doesn't own a house, but hey, they've got a good credit rating. So the system has to make a call. Based on everything it's learned from that history, with all those correct answers, what do you think the verdict should be? This is the absolute core of supervised learning, predicting an outcome for something new that it's never seen before. And this brings us to the official definition. Supervised learning is when your data is labeled with these predefined classes, like approved or denied. It's like a teacher, that's the supervision part, is standing over the machine's shoulder, giving it all the correct answers so it can eventually learn to make these decisions on its own. But this learning process, it doesn't just happen magically all at once. It's a really structured two-step process, and getting it right is absolutely crucial. First step, we have the training step. This is where the machine just grinds through all that labeled data and builds what we call a model. You can think of it like a recipe or a set of rules for making decisions based on the patterns it found. Then, step 2 is testing. We take that shiny new model and we show it brand new data it's never seen before, just to see how accurate it is. So the flow is pretty simple, right? You feed the labeled training data into a learning algorithm, and that spits out your model. Then you use test data to check how good that model is. The ultimate goal, of course, is to end up with a model that's incredibly accurate at making predictions on new stuff. So that all makes a lot of sense when you have a nice, clean answer key. But what happens when you don't? And this is where things get really, really interesting. What if you have a mountain of data, but none of it is labeled? No yes, no no, no approved or denied, just raw information. How in the world can a machine possibly learn anything from that? This picture just makes it so clear. On the left, that's supervised learning. The data comes with neat little labels like square and triangle. But on the right, it's just a jumbled of raw images. The machine's job is totally different now. It's not trying to predict a label, it has to find groups all by itself. It has to look at that mess and figure out that, hey, these pictures kind of seem to belong together in a dog pile, and these other ones look like they belong in a cat pile. And that is unsupervised learning. The class labels are totally unknown. The entire goal flips from prediction to pure discovery. You're not asking the machine to confirm a guess you already have. You're asking it to find patterns and generate a guess for you. It's about finding structure you didn't even know was there. And I guarantee you have seen this in action, maybe without even knowing it. It's used for market segmentation, where companies find natural groups of similar customers. It's the magic that powers recommendation engines that suggest products or movies by finding things that are often bought together. It can even be used to automatically clean up grainy old photos by identifying what's signal and what's just noise. Okay, let's pull all this together and put these two powerful ideas right next to each other so we can really see the difference. Here it is in a nutshell. The goal of supervised learning is prediction, and you do it with labeled data. It's just like learning with a teacher. The goal of unsupervised learning is discovery. You do it with unlabeled data, and it's like you're a detective, finding the patterns all by yourself.
So if you remember just one thing from all of this, make it this. The whole game changes based on the presence of that answer key. Is the machine learning from answers we already know, or is it discovering the structure all on its own? That one distinction is so fundamental to the entire world of AI and machine learning. And it leaves us with a pretty incredible question. Now that we have machines that can learn with a teacher and machines that can learn without one, what are the next great problems we're going to ask them to solve?